OSI model the secret blueprint behind every internet connection. This 7-layer system is the backbone of modern networking, and I promise, you'll be hooked from start to finish. Hit that subscribe button, and let's decode the internet. Imagine this: a Windows PC and a Mac want to share data, but they speak different languages. How do they communicate without chaos? Enter the OSI model, created in 1984 by the International Organization for Standardization. It's like a universal translator for networks, breaking down data transfer into 7 layers. From your browser to undersea cables, this model makes the internet work. Ready to uncover its magic? Let's dive in. The OSI model, or Open System Interconnection Model, is a framework that standardizes how data travels between devices in a network, whether it's 2 laptops in your house or a server in Japan talking to your phone. Picture it as a 7-story building, where each floor handles a specific job to ensure smooth communication. From physical cables to your web browser, these 7 layers: application, presentation, session, transport, network, data link, and physical work together like a well-oiled machine. Let's climb the stack. Starting at the top, the application layer is where you interact with the internet. Think Chrome, Skype, or Outlook. But it's not about the apps themselves, it's about the protocols that make them work. Protocols like HTTP for web surfing, SMTP for emails, FTP for file transfers, and Telnet for virtual terminals power your online activities. This layer provides the services your apps need to connect to the network, acting like a bridge between you and the digital world. Without it, your browser would be a blank screen. Next up, the presentation layer. This layer takes data from the application layer like text or numbers and translates it into a format computers understand: binary. For example, it converts ASCII, EBCDIC for compatibility. It also compresses data to make transfers faster, like shrinking a video for streaming, using lossy or lossless methods. And for security, it encrypts sensitive data with protocols like SSL, then decrypts it at the destination. Translation, compression, encryption. This layer's a triple threat. Think of the session layer as a party planner for your data. It sets up, manages, and closes connections between devices, ensuring smooth data exchange. It uses APIs like NetBIOS to let apps on different computers talk. Before data flows, it handles authentication, verifying your username and password, and authorization, checking if you have permission to access a file. It also tracks sessions, like ensuring text and images from a website download correctly. Without this layer, your connections would be a chaotic mess. The transport layer is the traffic cop of the OSI model. It ensures reliable data delivery through 3 key tasks: segmentation, flow control, and error control. It breaks data into smaller segments, each with a port number to reach the right app, and a sequence number to reassemble correctly. Flow control balances data speed, say, slowing a server sending 50 amps to match your phone's 10 amps limit. Error control uses checksums and automatic repeat requests to resend lost or corrupted segments. Protocols like TCP reliable for emails and UDP fast for streaming power this layer. The network layer is the navigate, guiding data packets across different networks. It uses logical addressing with IP addresses IPv4 or IPv6 to identify senders and receivers. Routers live here, directing packets to their destination using protocols like OSI or BGP to find the best path. For example, if you request Facebook.com, the network layer ensures packets from Facebook's server reach your device, using IP addresses and subnet masks like 255.255.255.0 to route efficiently. It's the layer that connects the world. The data link layer handles local delivery, turning packets into frames with physical MAC addresses, unique 12-digit codes embedded in your device's network card. It manages data transfer over physical media like Ethernet cables, optical fibers, or Wi-Fi. Using techniques like media access control MAC, it prevents data collisions on shared networks with carrier-sense multiple access CSM. It also adds error checking bits to detect corrupted frames. This layer ensures your data gets to the next stop flawlessly. The physical layer is where the magic meets the metal. It converts binary data into signals: electrical for copper cables, light for fiber optics, or radio for Wi-Fi, and transmits them over physical media. At the receiver, it converts signals back into bits for the data link layer. This layer defines the hardware, cables, connectors, and signal types. Without it, there's no connection. Think of it as the internet's foundation. Here's the big picture. When you click a link, the application layer starts the process, presentation translates and secures data, session manages the connection, transport ensures reliability, network routes packets, data link handles local delivery, and physical sends signals. At the receiver, the process reverses, delivering data to your screen. The OSI model is the unsung hero behind every email, video, or game you enjoy. Wow, the OSI model is a networking masterpiece. Now, you know how data zips around the globe flawlessly. Want more tech deep dives like this? Smash that like button, share this with your tech-loving friends, and subscribe to Cybersage for more mind-blowing lessons. Drop a comment. Which layer fascinated you most? Let's geek out together. See you in the next video.